Block storage. If you're anything like me, you probably never really spent too much time thinking about this topic. And let's be honest, if you were involved with capacity planning, like I used to be, you typically work out how much storage you need, then multiply it by 3, and then just pray to the gods that you don't run out of disk space. And that's pretty much been the way that everybody has done storage capacity planning until today. But there is a smarter way to do capacity planning, tightening those purse strings and removing the need for those midnight out of disk space emergencies. In this episode of our FinOps webinar series, we'll be talking about innovative solutions that not only reduce the block storage costs, but actually improve uptime too, which sounds quite a lot like having your cake and eating it, which is possibly why people in the IT industry have got so fat. I'm Nesh. I'm a senior solutions architect at GlobalDots. Who are GlobalDots? We are cloud innovation hunters, and that means we're constantly scouring the globe for new innovations, and we find the very best of breed, and we bring that technology to you first. So hopefully we're showing you technology that you've either never seen before or had no idea it existed. In today's show, we'll be talking about cloud storage, and I'm joined by Nitin, who's a co-founder of Lucidity, which specializes in storage optimization. Now, Nitin, in the nicest possible way, of all the areas of FinOps that you could have focused on, EBS is definitely the least sexy. What on earth led you to think about EBS storage as a focus point for your career?
Thanks, Nesh, for a great introduction about why storage should be ignored. But to be honest, one of the biggest reasons why storage was attractive for us was, one, in absolute terms, storage is $60 billion industry, growing 30%. After compute, this is the next segment which every customer attempts to. So yes, it's not insignificant. Second, the biggest reason why storage was exciting for us, that 60 to 70% of the data, world's data, still reside in data centers. So it's bound to move to the cloud. In fact, it's moving as we speak, post-COVID. So yeah, you would have huge disk data moving to the cloud, which would be asking for solutions to optimize the storage. So that's the business angle to it. But actually, we have a personal story to share that why storage was exciting for us. So I would attribute it to my co-founder, Vatsal. So Vatsal was handling a massive AWS spend at one of the biggest unicorn in India. And he was given a responsibility to optimize cloud storage cost. And as every engineer, he attempted compute first and potentially skipped storage. The reason why storage was skipped, because there are very few products out there in the market to optimize storage, and it's a significant effort for DevOps team to do it, for engineering team to do it. And the second is there's a perceived risk. There's a data you're talking about. So anything tinkering here might attract the CIO's frown. So that's the reason we decided, I think there has to be a intelligent way to manage storage, and Lucidity was born.
Great. And I totally agree with you that everybody would focus on compute first when they're looking at their FinOps optimization. It makes the most sense because it's the largest part of the bill. But it seems like in the last year and working with other solutions around not just EBS, actually S3 and some other things, but particularly it seems like in the last 12 months or 12 to 18 months, we've seen the conversation gear more towards that, or the conversation has really started around that. Any theories as to why we're having more conversations about it, or what brought it into light?
I think I would attribute to it was writing on the wall. It was bound to happen. So if you look at the FinOps as a concept, it's a 5 or 6 year old concept which has taken into midstream. And when this concept came, everyone started focusing on compute. In last 2 years, if you talk to every FinOps guy in every company, they would have done basic levers of cost optimization, and they have exhausted everything they can. A lot of them, at least not all, but a lot of them. And now they're stuck at storage. Now they're thinking about okay, what can we do here? So there are very basic levers out there for storage, but beyond that, they're struggling. And we have a couple of customers who actually categorically told last year that, hey, Nathan, I like your solution, what you guys doing, but I'm focusing on compute. And I will myself will come next year to you and say, hey, I need now solution for storage. So I think it's time that it was just a sequence. So that's the one of the reasons.
Makes total sense. And being in the sales seat, I would sort of agree that it's just something that people are getting around to. Basically, it's one of those long-running tasks somewhere in the background for somebody to look at that and just waiting for the eyes to get there. Basically, Nitin, you have your ears very close to the ground with the industry of storage, particularly in public cloud. Let's jump through some of those numbers and what they look like in the real world.
So sure. So why don't you let me tell you about what we have observed after working with almost 100 plus enterprise customers and looking at their environment. So for this today's discussion, we will restrict to our observation on EBS, which is AWS block storage. Block storage is the high performance storage where you use basically you attach these disks to every EC2 instances. You use for a different application, and it could be whether you're using for Kubernetes, it could be under the background, it will be EBS volumes and so on and so forth. Now, I'm using AWS EBS as an example, but the concept and the observation remain exactly same across Azure and GCP as well. Now, if you look at EBS cost, it's actually anywhere from 5% to even 45% of a cloud cost bill. It's completely dependent on how you have architected. So we have seen mid-market customers who were cloud native. If they are very heavy on PaaS, probably their EBS spend could be 5%. Then there are customers who were on data centers before and they have done a lot of lift and shift. They probably are a lot more on IS architecture, and that's where the cloud spend as storage as a spend of cloud spend would be around 45%. But in general, what we are seeing that the rule of thumb 10 to 15% is a good benchmark of EBS spend. Now, there are a couple of levers which organizations use to optimize storage. Like in AWS EBS, they will do GP2 to GP3 or idle volumes. But the biggest lever, which is often missed, is the disk utilization. You'd be surprised to know that when we did an audit of almost 100 plus organizations, we found the disk utilization was hovering around 25%. What it means, if you have 1 petabyte of disk spend, which you're paying to AWS every day, potentially the data usage could be around 200 to 250 GB. We're talking about 750 GB as a buffer, which you are paying to AWS every day. And the reason is organization, as Ganesh initially started this discussion, just multiply the data usage by 3 and just pray to the God, because they don't want to end up into a situation of downtime.
Completely makes sense. And none of this data actually surprises me whatsoever. If anything, I'm surprised it's even 25% utilization, because usually if you're in the business of covering your ass, you want to leave a lot of space in there. You mentioned on this slide, yet downtime in spite of over provisioning.
Yes.
Can you talk to that?
Oh, absolutely. So I don't know how many of you guys remember incident December 2020. The whole world got logged out from Google for almost 40 minutes and we were not able to log in. And the reason was, guess what? Google logged out in their storage space. So one of the system to upgrade the volume failed. So imagine the plight of Google having a downtime because of their system didn't work out. And imagine the plight of other companies. So yes, yet you will have a over provisioning, and yet organizations we have seen once in a quarter or 6 months, they do face downtime in one or the other disk. And these is such a fast situation that when a CIO asks a CTO that, hey, how is it possible that 95% of my disk are over provisioned and yet we had a downtime? And that's where they start realizing that they need to automate EBS. The current process does not work.
And I echo that sentiment. It's so often is the case when we're talking about any innovative technology. And if there's a case of it happening to Uber or Facebook or Netflix or Google or something like that, it's like, guys, if it can happen to Google, it can happen to you. You know, it's a very, very sentient point, and that's that's a great contextualization. Let's have a look at the industries themselves. And again, I would sort of echo to anybody watching that these are real life numbers. These are not hocus pocus magic numbers that we've made up. They're really taken from the industry. But Nitin, walk us through some of these numbers.
Sure. So we just wanted to put up some numbers. Wanted to show you that, first of all, this problem exists across industry. Doesn't matter which vertical you belong to. This is how AWS or Azure or GCP is managed. So if you look at even Fortune 500 company, the disk utilization is hovering around 17%. Or if you look at a mid-market stage company, the percentage will not be very different. And it has nothing to do with geography. I mean, be it US, be it Europe, be it India, there's always a fine balance. Obviously, some geos might be doing a little better, but overall, the disk utilization is happening around 25 to 30%.
Yeah, and there was not a single number on there that's above 30%, which exactly fits my mantra at the beginning. Work out how much you need and times it by 3. Those numbers are pretty clear. What isn't so clear is disk's downtime. Can you just walk us through what disk's downtime means?
Right. So these are the number of disks which faced a downtime or which ran out of disk space in last 6 months. So obviously, as you can see, there have been the first row where the disk utilization was very high, the downtime was less. And then there were some companies which is not fairly well managed, and they didn't put up some monitoring tool, and which led to more downtime. So these are the instances where they had 1 o'clock call from SRE team that one of the disks is actually not available.
Okay, perfect. And I think that leads us very nicely to the next part, where let's talk about some of those pain points. We know that people have problems picking the right size. We see from this that people are having disk outages or disk downtimes, whatever you want to call those, which either suggests there's an inefficiency in monitoring, or there's just a global wide problem with catching this, which I suspect probably both is maybe true.
So yeah, thanks for this, Ganesh. I think this is very interesting observation when we actually looked at infrastructure challenges. And if I have to summarize, there are 4 pain points why over-provisioning exists. The first one, you already nailed it. The way capacity is managed, it's a guesstimate game. Simply take whatever data you have multiplied by 3, and you will have like 70% wasted from day one. That's one. The second reason is the way EBS or block storage is managed is fairly manual process. Now, how our organization right now manages it? So first they put a monitoring tool like Datadog, then they hitch it up with the alerting tool like PagerDuty. Then DevOps person gets an alert, and he can get an alert in morning, night, anytime. And then either he'll go manually and provision and upgrade the volume, or he'll probably run a Terraform script to do that. Either way, there is a last step of manually letting the operating system know about a new upgrade possibility. All in all, the summary is basically you can manage it when you have 10 VMs, 20 disks, 30 disks. But the moment you start scaling beyond 500 disks, 1,000 disks, it's become practically impossible that if you have to manage all of this by stitching 3 tools with a DevOps effort, you would rather want to keep a significant buffer. You don't want your SRE team to keep getting call in morning, right?
I completely agree on this point. And even the description of that sounds like a DevOps SRE waking nightmare. Just endless alerts and endless. I like the way you're stitching together of Terraform. It's not pretty, and it's. I don't think most people listening will have never really thought beyond that there must be a better solution for that. I think it's so deep ingrained in the mindset that that's how we operate with disks that we have the blinkers on there.
In fact, if I just may add, Ganesh, on that point, that when we speak with a lot of customers and when we pitch to them the, hey, disks are not utilized fairly, a lot of time the CTOs, they come back and saying, no, we are fairly well utilized. Look at our disk utilization; it's actually 40%, and that's the definition that I think if you are hovering around 40 to 50%, that cost of doing business, which basically means no one isn't thinking in their wildest of imagination that is there a way to increase it to 80%, because they just think that this is how it should be run, right? So they fairly think that the current way of putting multiple tools is a very standard way and this is how it should be done. And a lot of times someone has to educate, no, maybe there could be a better way. So this is how it is done.
It's to think about it the other way, if you had an S3 storage bucket and you were paying for a petabyte, but you were only storing 500 gigabytes, nobody would be happy with that. Nobody on planet Earth would be happy with that. But we have this ingrained idea that you're right, it's acceptable with block storage.
Right. And another challenges which we have found, third reason why companies don't want to upgrade frequently is, if when you upgrade a AWS EBS volume, during that time, the IOPS takes a hit. So your application actually becomes a little slower. So for companies who are in sectors like gaming, blockchain, crypto, and they're very heavily rely on EBS volumes, and they don't want, or they're running transaction databases which cannot take any hit in IOPS, they don't want to do frequent expansion. They just want to keep a significant buffer and pray to the God that they will upgrade the volume probably in 3 months or 6 months. So they don't want to get in that upgrading frequently.
And I believe also, from my knowledge, not only is there an impact on the IOPS as you extend those disks, it's depending on how busy AWS is, this can also take an awfully long time.
Absolutely.
And you are limited in the number of times you can perform this operation. And in fact, it's essentially recommended that this is an emergency procedure, really. They offer it as a service. They offer it that you can do it in runtime, but it's not best practice. Nobody ever wrote a best practice document that said, keep on extending your ext4 volumes when you run out of space. This is essentially a bit of a no-no, and I would say a sticky plaster. And I used to have a boss and we used to do these kind of things. And eventually he said, we are the masters of sticky plasters. And I think probably that's what DevOps people have become. DevOps people have become the masters of sticky plasters when it comes to EBS storage.
Absolutely. Right. So I think these are challenges which everyone knows that this is capacity challenges and expansion challenges. But guess what? The biggest of all, let's say, even if we do a webinar, educate the whole world, hey, you know what? Your disk is over provisioned. Even if the CIO or CTO is watching it, probably will go to the DevOps team and say, hey, you know what? I've just learned that disk is over provisioned. Why are we wasting so much money? Please shrink it. I guess you would know the answer that DevOps would say, I don't think so. I would want to do that. And the biggest reason is because AWS, Azure, GCP, the block storage, you can't shrink without a downtime. So if you have to shrink a volume of, let's say, 1 terabyte, you believe you're paying massively to that, and you don't want that much of volume, you're stuck. Because if it is downsize, you have to spin up a new volume, transfer this data, do 20 plus manual steps, take a significant downtime, and no one likes to do that. So these are the broadly 4 challenges because of which EBS, if you ask, because of lack of any better technology, the current process considered business as usual.
And the shrinking requiring downtime piece, It's a bit like the drug dealer. You can always take more drugs, but you can't return them very easily. I think storage is like that. You can always have more. Great. We have a really compelling story, which is completely resonates with me, having been in a technical position in the past, and as somebody who deals with DevOps team leads and SREs and people in that world. I know this is a very real thing, and Global Dots is heavily in the world of FinOps, and we've had compute tools and lots of tools around reducing your cost. How do you intend to solve these four problems? Because it's a compelling story that we're in this situation. What's the solution, Nitin?
As the name suggests, we have built an EBS autoscaler, which is right now live on AWS, Azure, and GCP. This autoscaler has the capability to take your disk utilization from anywhere from your current 25 to 30% to almost 70 to 80% disk utilization. It is application agnostic autoscaler. So whether you have root volumes, data disk, whether you are running databases, MySQL, Kafka, and hosting it directly yourself, or even managing Kubernetes clusters, anything which uses EBS, this autoscaler works seamless. The benefit of this is it reduces your storage cost significantly. Second, it ensures you never have a downtime. You will never have a Google moment where you ran out of disk space. Plus, on top of it, I do understand that customers owe provision, so they might not be spending significant DevOps effort in managing it. But whatever amount of our team is spending in managing storage, we make that to almost zero.
Which is quite an interesting offering. Definitely will leave 99% of people confused, because we've just said that scaling disks is a complete problem and you can't scale them down, and you've just introduced a disk autoscaler. So aside from automating this sort of stitched together DevOps sticky plasters, but what is it exactly? What is the solution? How is this different to what's available at the moment?
So when we looked at the problem which you highlighted to you before, we knew that we have to build this solution completely ground up, because AWS does not support shrinking. They don't have any feature by which you can shrink a volume. So we have built a complete no-ops tool which has inbuilt monitoring, inbuilt alerting, and inbuilt implementation to expand or shrink a volume without any downtime. So what we have solved is that we have built a technology by which we can shrink a volume without any downtime. We can expand a volume without any manual intervention. And we can do that fairly quickly. Like literally 15 minutes deployment and 1 hour in ROI.
So you have to go deeper, because I'm very sure we have a technical audience. How is this actually working? How is it that we're able to extend and decrease where we don't hit the problems we have with like ext4 type volumes?
All right. So Ganesh, probably you're asking me to spill the beans of our magic sauce. So, but that's fine. That's why we are here for. So let me take you through how we have built it. So we have used a very age-old concept of logical volume concept. So this is a fairly well-used concept used by multiple companies, but it's a very hard to implement it. And so we took that concept and we made it 10x better. So just for the audience here, let me take an example of shrinking. That why does it take a downtime? The reason is, if you have to shrink a bigger volume, you have to spin up a smaller volume, transfer this data, unmount and mount. This action leads to downtime. Now, we completely eliminated this need and we came up with another concept. The way we did was, we took that same 1 terabyte volume and we split into smaller individual EBS volumes. And we created a logical volume concept on top of it. So what it means for an application developer, he still sees that D drive as a 1 terabyte partition. Nothing changes even after Lucidity is deployed. But If you log into AWS console, now instead of 1 terabyte volume, you will find smaller shards or smaller EBS volumes created, which are stitched together as a logical volume concept. Now, once this is onboarded, then shrinking becomes very easy. So if I have to shrink a volume, we talk to the file system ext4, and we talk to the file system and basically transfer this data, let go of one smaller volume, and that moment onwards, you stop paying, let's say, additional 250 GB to AWS. So from 1 terabyte, you have now shrunk your disk to 750 GB, and it didn't involve any downtime. And you can do this operation 100 times in a day without any manual intervention. This is how shrinking we are able to do it. In expansion, it's a lot easier. In expansion, we just call up a new disk, attach to that VM, and create a logical volume concept again. Mm-hmm. This action is fairly quick. You can be able to do it in probably 1 minute, which, to be honest, right now takes almost 3 to 4 hours in a 1 terabyte volume.
So it's still based on ext4, and if I was to kind of summarize, it's EBS volume sharding, I suppose, would be like a technical description, but really it's just an age-old technique of using mount points, really.
So the file system used are different. For Windows, we use the native file system, whatever they're on. For Linux, we use a very heavily used BTRFS file system to extend this capability.
Mm-hmm. So just in case anyone's listening and you never heard of BTRFS, it's BTRFS or BTFS?
Yeah, BTRFS, yes, yeah. Butterfs, yeah.
So just in case for anyone listening, you never heard of BTRFS, we don't blame you because nobody's using it hardly at all. But it was a new kind of file system that was created that enabled this sharding of EBS disks, if you like. So it's taking something that's existed for quite a few years and finding a production-based application for it.
But Facebook is heavily using Butterfs. They are the one proponent of that. In fact, this file system is loved by SUSE so much that SUSE use now BTRFS as a default file system. So this has been in operation from last 15 years, getting cooked, baked again and again, and getting better and better. And it's a very powerful system, which is now being adopted by a lot of customers.
I can't believe it's the first time I'm hearing that Facebook use it. That should be like number one point on the agenda. How does Facebook scale their disks at mass? It's using the BTRFS file system. That's cool. It's also people sometimes call it the better file system as a shortcut, but I actually prefer butter. Some people call it the butter file system, and I don't know, there's something quite fun about butter. So the butter file system. Let's go back to your solution. So we have an understanding of the butter file system. We understand this, what I'm calling EBS sharding, probably incorrectly, but let's jump into a use case about that.
Let me talk about one of our most loved cloud customer who were on data centers before and moved to the cloud. And they have significant spend on storage, and they were struggling. They were trying to find solutions. So this particular company, unfortunately, can't name them because it's a fairly big enterprise company. They were spending almost $203,000 on managed disk on a monthly basis, and this constituted almost 40 to 45% of the cloud spend. And the disk utilization, as expected, when we ran an audit, hovered around 23%. So they had like 197 VMs, which had some 661 disk drives, for which they had only 557 terabyte data. And they were paying every month 2,254 terabyte to the CSPs. So that's the kind of savings which, first of all, they were not even aware of. They were not even aware about disk utilization, which we helped them uncover it. And then if you move to the next slide, we were able to show them that if using Lucidity Autoscaler, they would be able to take your disk utilization from almost 23% to 75% on an average. Now, why I mentioned is on an average, because there would be a disk, which is a fairly big volume. We can even take this disk utilization to almost 90%. And then there will be smaller volumes like root volumes, where potentially might be the disk utilization would be around 50 to 60%. So hence, we are able to guarantee almost 75% disk utilization. So if with our autoscaler, we'll be able to move there, then their monthly bill will reduce from 203,000 to 105,000, which is almost 46% cost savings. And guess what? This includes lucidity charges. So whenever we quote to customer, we quote including our charges that they would be able to save $1 million, which is a significant amount considering the amount of spend they were having on storage.
That's a great breakdown. Obvious benefit to the solution. I know that speaking to people in these roles, the first question that is going to hit their mind is, how is this going to affect my uptime? It immediately sounds very risky that you have something messing around with your storage. You know, it's one of those things like if somebody mentions, don't worry, it's just a kernel patch. You know, there's something that inside an IT engineer that starts to shiver. So give us some comfort around that.
So cost savings actually, Ganesh, is one of the immediate tangible benefit which customers are able to realize. But actually, they love a solution. They take a solution for cost savings initially, but they stick with us for automation. So one of the key facets which we are able to provide as a value is server downtime. So for this particular customer, they used to face, because they had massive spend and massive big disk, they used to face these kind of downtime situations. Now, I'm not saying that these are downtime, these are hours of downtime where they actually had server missing out the disk on. And we are able to promise them that you would, with lucidity, will have absolutely zero downtime. And one of the reasons why we are able to confidently claim that is because of two things. One, we are able to auto scale a disk within 1 to 2 minutes notice, which is practically not possible in current scenario. That's one. Second, we are eliminating the need for any stitching up of 3 multiple tools. So our product itself has monitoring, alerting, and implementation all baked in one. And as the logic would have it, if you don't have multiple parts stitched up together and the current product can scale up within a minute's notice, you will end up never have a downtime situation. So this is, along with this cost savings, is another benefit which the companies have been able to realize. And the third one is DevOps effort. So this particular customer used to have very workload seasonal data coming in. So they would have, let's say from January to March, they will have some data coming in. So every weekend, the DevOps team have to continuously put an effort to upscale the disk. And then when there's a lean season, the same team have to put an effort to downscale it, which by the way, they never did. Mm-hmm. So with our solution, in fact, more than cost savings, as you would know, the FD effort is a fairly significant amount. And this is also one of the value addition which customers are able to realize it.
That's a very, very good point to argue.
Yeah. So when you were doing audit of customers and when we were able to give them a breakup that, hey, from where are we making you realize this cost saving? So as you can see here, there are three bigger levers. One is the idle resources. This is the low hanging fruit, which most of the FinOps companies would figure out to do it. But this is not the lever by which the most of savings get realized, but our tool also gives that visibility, by the way. And we don't even charge for it. It's actually absolutely free. The biggest lever which we are able to optimize are underutilized resources, which I've been talking about for so long. But the third one, and this is a very interesting case, there were literally 11 VMs where those were very highly utilized. And if you're putting lucidity on top of it, customer was actually losing money. And yet, when we showed them that, hey, these are the 11 EVMs, and do you want to put lucidity on top of it? They have an option not to put lucidity on top of it. And they, without a blink of eye, they said, I want to. Because for me, these 11 VMs it's not the cost savings which is more important. These are my critical VMs, and I don't want to run in the situation where my monitoring tool was supposed to give me an alert and I should have upgraded it, but somehow something happened and it's not upgraded. So ideally, I want to put Lucidity there so that I never have a situation of having a possibility of downtime.
Very compelling. It seems one of those things that's almost too good to be true, because you're improving uptime, it's costing less. My assumption is that because we're using multiple volumes underneath, that we get the benefit of the IOPS as well. So we're probably, and you're nodding, so yes, we improve the IOPS as well. Seems too good to be true. There must be some kind of a catch. Is there? We mentioned that you can use it for different database types. You can use it for Kubernetes clusters. You can use it for what I would call like full fat VM instances, or just thick instances. Like where is this not a fit, or what is something that would stop this from seeming to be too good to be true?
Right. So as I mentioned earlier, this solution is useful for anywhere there is an IaaS offering wherever you're using EBS directly attached to EC2. This is not applicable for any PaaS solution like RDS or anything which is managed by completely AWS. Because the way the solution works is you have to deploy an agent, and that agent would have the provision to basically manage those disks. So a PaaS offering like RDS does not allow you to do that. So that's the places it will not be useful. Beyond that, yes, I mean, that's the reaction we get from customers, that it is too good to be true. And in fact, we have so many customers talking about that. Okay, where were you guys before that? And we were like, we were just building in background, and there's no other catch. I mean, yes, it requires an agent deployment, but I think so does Datadog and other 20 other tools. We don't don't have any customer access to the data. We only work with storage metadata. We don't come in IO path. So because of these reasons, security team loves us, and we have the best of all. We can self-host the whole Lucidity autoscaler in customer environment. So I mean, we are able to sail through most of the security aspects of it. So I think I would say this product time has come, and hoping like what autoscaling group did for AWS. So now everyone uses ASGs, and which is the de facto standard. For us, this is a benchmark that there is no autoscaling for EBS. So using now autoscaling group and autoscaler of Lucidity for EBS is the best combination. And I think the future, everyone should be using it.
I think you're probably right. And, I've been looking at this technology a little bit, and I've become more and more convinced that actually this is completely brilliant, and that it's a miracle that somebody didn't think of it already. Actually, it's one of those ideas that's so good you can't believe that somebody didn't think of it already, which to me is a sure sign that you are on the way to becoming a full-blown Indian tech unicorn. And I'm convinced that we can overcome any kind of technical fear from the community, because there was a time when nobody would use spot instances for compute loads in production. It was considered far too risky, and the risks of downtime, etc., etc., etc. Now everybody runs production workloads on spot instances, and they have 100% uptime. So flipping the same mentality to think about EBS volumes, that's essentially what we're talking about, really. It's a bit like spot instances, but for EBS volumes. And I think the time is right. I think it's a very interesting technology, and I think there will be plenty of people interested in that. We managed to take quite an unsexy topic of EBS, and actually on unwrapping it, it turns out that it is a pretty interesting topic. And Nitin, you are, I would say, probably one of the top leading professionals on storage in this way at this time. So Now we see this as the immediate future, what we can do with our storage. What are any thoughts on the future of this problem, or the future of storage and costs generally? Where are we going with this?
Right. So I think, as I mentioned earlier in our discussion, that significant data from data centers is moving to the cloud, and those big storage boxes are going to move. So customers are going to asking this kind of intelligent solution, right? Solution which we just spoke today about one of the problem of auto scaling disk based on size. There are multiple problems right now exist in the market in storage. Just to give you an example, auto tiering between disk. Like for example, GP2 to GP3 is a very simple concept AWS came up with. They gave a clear button, go and just convert it to GP3. But guess what? It's been 2 years, GP2 has been launched, and still 100% adoption is not there. I mean, you would find a lot of customers still on GP2. Now, the question to be asked here is, why is it dependent on a DevOps person to decide what tiers of storage should I move to? Why can't there be technology which will automatically decide based on data access pattern which tiers I should be keeping to? So a lot of these solutions I think will come in the market. The way we look at it is that's why we coined the term no ops for cloud storage. We believe in 5 years, a lot of these decisions would be automated. Which storage to provision, which storage tier to provision, what should be the size, what should be the IOPS, should I keep this data in block storage, should I keep this data in object storage? Think of it as a layer which will automatically decide what do you do with the data. For that matter, whether it even makes sense to move this data back to some other CSP providers. I know there are the egress charges and I don't want to get there, but this is what we are envisioning. So storage would be the focus the moment these data center boxes will go, and the customers would be asking for these intelligent features.
That is a totally awesome answer. I completely agree, mostly because I'm thinking about IOPS. IOPS is a complete mystery box, and nobody apart from maybe like 10 people in the whole world really understand that and what an application needs. And I think it's something that it needs to be handed off to machine learning. And when we fully get to that point, I hope Lucidity is there with a new offering that can help people on this journey. So as we wrap up today's episode, I hope we managed to shine a light in the dark corner of cloud block storage. Remember, that was not just talking about lowering costs. We were talking about improving performance and scaling in an efficient way, flipping that mundane task of storage optimization into an easy job with next generation magic tools. If you're ready to deep dive and start transforming the way you approach FinOps in general, then myself and the team at Global Dots are at your disposal. It's what we do, and if I don't say so myself, we do it pretty well. So have a word with the experts, don't be shy, and remember that conversations are always for free.